Okay, so recall when we first talked about how to solve an exponential equation, we talked about if we had the same base, if we had a common base, or if we were able to rewrite it so we could have a common base. So that was one method of solving exponential equations. But what if, even if we rewrite it, there's no way that we can have a common base? It's just not possible at all. So that's what we're going to talk about now is if we have an exponential function and it's just not possible to have a common base. So the first thing that we want to do is isolate the exponential expression. So that means that we want to isolate that base raised to a power. And then we're going to solve it like a log equation. So we're going to take the log of both sides. We may need to expand the log using the power rule. And then we're going to solve. This next part, though, is so important. You have to check for extraneous solutions. So remember that you can't have a log of a negative number. So please make sure that you check for extraneous solutions. We're going to have to check our answers and make sure that they work. And then this is important too. Rounded answers may not produce the exact same answers, but they will be very close. So when you're checking your answers, just keep that in mind. Okay, so let's do an example of how we solve these types of equations. So we have 4 times 7 to the n equals 148. So we're like, well, let's see what happens because maybe we can write this as the same base. Let's go ahead and divide both sides by 4. We get 7 to the n equals 37. And we know there is no way we can rewrite 37 with a base of 7. So that means that we cannot have a common base. So we're going to take the log of both sides. So what that means is you can either rewrite this as a log. How I learned to do it was literally just to take the log of both sides. So you can do it that way. But I have also had many students that just rewrite it as a log. So that means our base is 7. 37 goes here and n goes here. And then we just have to use our, sorry. We don't have a base of 10 here. So we have to use that converting it and how to put it in our calculator. So that would be log 37 over log 7 equals n. All right. The way that I learned it was to literally take the log of both sides. If you can't remember, if you struggle with converting an exponential function to a logarithmic function, then this might be better for you. You just have to remember those properties of logs because we have to move this n down in front. So we have n log 7 equals log 37. We want to solve for n, which means we're going to divide both sides by log 7. And so we wind up with the same thing, which is log 37 divided by log 7. So it's really, these are 2 different ways to solve this problem once you get a single log equals a number. So you can leave your answer like this in terms of logs, or you can put it into your calculator. And when you put in your calculator, you're going to get 1.8556. And then, of course, we want to check that. We would go back and we would be able to get the right answer. So this does check out. Okay, let's do another example. So again, the first thing we want to do is we want to isolate that exponential equation. So we're going to isolate the 16 to the 7y plus 2. So we add 2. And then we're going to divide through by 6. So we're going to get 16 to the 7y plus 2 equals, let's see, 84 divided by 6. That is 14. So 16 to the 7y plus 2 equals 14. We can see that we cannot rewrite them at all to get the same base, which means that we have to treat this, we have to convert to a log equation. So we can take the log of both sides. I'm going to do both ways for you, or you can rewrite this as a log. So let's rewrite this as a log first. Our base 16, 14 equals 7y plus 2. That means then we would have log 14 over log 16 equals 7y plus 2. And this is where it gets a little crazy and messy. If you want to keep writing this as logs, where your answer contains log, which I am fine with, then we would subtract 2 from both sides. So we would have log 14 over log 16 minus 2 equals 7y. Then we're going to divide the whole thing by 7. And so this would be your answer for y if you kept it in terms of log. Now let's look at the other way where we take the log of both sides. So from here, if we didn't want to rewrite it as in the log, converting to a log, and we just took the log of both sides, that would be log 16 to the 7y plus 2 equals log 14. Then we remember the power rule. We're going to drop this down in front. 7y plus 2 log 16 equals log 14. Divide both sides by log 16. And again, we have the same thing. So we're going to solve it the same way. We subtract 2, divide by 7. We'll wind up with the same thing here. So if we put that in our calculator, you'd put it in log 14 divided by log 16, hit enter, subtract 2, divide by 7. What you will get is that y equals negative 0.1497. Now again, I am fine with however you want to solve this. Sometimes this way can be trickier because you have to show me all of those steps, but I highly suggest you do that anyway, because if you put it in your calculator wrong and this number is not correct, I can look back and see that you knew how to solve these problems. So if you're going to do it anyway, you may as well make it your answer, and then you don't have to plug everything in your calculator. But it's up to you. But that is what we do, how to solve exponential equations if there's no possible way we can write a common base.